During the fast expansion and growth of the Industrial Revolution which followed, large corporations sought to build the industries of the 20th century that were needed to sustain the competitive growth and production in the Western world. Managers quickly came to see that profit and growth were tied to their ability to manage their costs, while learning to control larger and larger human enterprises. It quickly became clear that a new science was needed to more efficiently manage and direct a growing number of people to do more and more complex tasks. It was upon the current fundamental bedrock of the clockwork universe that the solution was born. In 1911, in his landmark book, The Principles of Scientific Management, Frederick Taylor, using the very models established with the clockwork universe, described the foundations for how this could be accomplished. And we can find the influence of this worldview on Taylor's thinking. For example, on page 26 of his book, he stressed the importance of management providing training as a basis for boosting proficiency, developing a, as he called, close, intimate, personal cooperation with workmen as the essence of modern scientific and task management. On page 41, he borrowed from Descartes when he established the idea that people were part of the factory machinery. In his own words, in almost all of the mechanic arts, the science which underlies each workman's act is so great and amounts to so much that the workman who is best suited actually to do the work is incapable, either through lack of education or through insufficient mental capacity, of understanding this science. On page 36, he borrowed from Newton's concepts of laws of motion when he suggested that these concepts could be applied to industries, when he wrote, "The managers assume, for instance, the burden of classifying, tabulating, and reducing this knowledge to rules, laws, and formula, similar to the laws of classical physics." And on page 31, he applied Darwin's theory of evolution in describing how work gets done. He wrote, "Thus, the methods which are now in use may, in a broad sense, be said to be an evolution representing the survival of the fittest and the best of the ideas which have been developed since the starting of each trade." Thus we see the first real application of many of the key methods proposed and developed before him as applied to large industrial management. Today, while many have expanded on Taylor's concepts and ideas, nearly all of the fundamental concepts put forth in his book, The Principles of Scientific Management, are retained in whole and applied in today's business world. And also today, we can see how early software development organizations took directly from the manufacturing industries that preceded them, embodying the very essence of Taylor's management style in defining how to manage human-intensive, complex software projects. In fact, we can, with some accuracy, map the management tools and techniques we use today to these fundamental clockwork universe concepts. Here we see the effects of this paradigm on the development and use of tools in managing software development. Galileo's emphasis on measurement has led us to focus on what can be repeatedly measured. We can see how Descartes' concepts of functional decomposition is applied not only in how we organize massive amounts of people, but also in how we deconstruct and distribute large amounts of work and assign responsibilities to groups and individuals. From the concept of cause and effect thinking, like billiard balls, we developed the basic waterfall development lifecycle method, which even today is the most followed method to managing the development of software. From the emphasis of survival of the fittest, we apply the idea that we should eliminate redundancies from the system by letting only the most fittest of methods survive over time. And using Taylor's concept of eliminating waste in the operations of a business, we have come to see the importance of predicting future outcomes of our projects, statistically controlling our operations, and reducing work efforts and costs over time. So far I have described how the clockwork universe concept led to how we currently manage software organizations and projects, but I haven't discussed how this has influenced how we improve them. Yet, if we take the constructs I have presented here, we can see how the methods developed over time have influenced our view of improvement. It isn't too surprising that when our software companies turn to identifying ways to improve how they operate, from engineering to resource management to decision making, we automatically begin to construct our processes and quality improvement strategies from this same clockwork playbook. The scientific method has taught us, for example, to focus on deriving repeatable and consistent measurements. Functional decomposition has led us to decompose our corporate improvement goals and allocate them to divisions, departments, and branches. Even our processes are prescribed, hierarchically structured, and handed down with extensive emphasis on task-focused decomposition. Even our improvement models, such as the CMMI, are functionally structured and directly applied using the same paradigm. Cause and effect thinking has led to looking upstream for the sources of problems that we've identified and specifically looking for the relationships between the causes and effects. The law of survival has led us to drive our companies to extensive standardization of processes and procedures. Roles and responsibilities are assigned with great detail, while policies set limits and constraints on what people can decide or do, all in the name of the company's survival. And nearly all improvements are heavily influenced by the Taylor's idea of eliminating unwanted waste. So statistical control charts and analysis are used to establish performance limits while working extensively to trim operational fat from our processes. By now you're probably asking yourself the question, okay Jim, I understand all this, but so what? It seems to me that this idea of the clockwork universe has worked pretty well up until now. This view of the world has helped us to construct the necessary tools that we've needed to get us through the Industrial Revolution. It's given us the necessary insights into how to build a modern computer. And it also, today, is helping companies, executives, and managers to efficiently manage the construction of very complex software. All of this seems pretty good to me. If you are saying that question, then I would have to agree with you 100%. The clockwork universe idea has been all of these things, and probably a whole lot more. But my question isn't so much about the past as it is about the future. The question that I'm asking is more, will this clockwork universe view of the world continue to be an effective foundation for how we manage and improve software organizations and projects in the 21st century? We are seeing, I think you would agree, unprecedented levels of change in all aspects of software industry. And we need to modernize our thinking as well as the tools and technologies that we use. In the next part of this video, I will describe why I do not believe the clockwork universe view is adequate, and I will also give some insights into a different worldview, one that I do believe will allow us to expand our existing set of tools that we use today to manage as well as to improve our organizations. I hope you'll stick with me. Thank you. If you are looking for more information about how to use systems thinking in software engineering, I hope you will take the time to check out my book on the subject, Discovering System Dynamics in Software Engineering. You can either purchase this book directly at Amazon, or you can find a link to the Amazon page at my company website, www.spdynamics.com. For more information about how to apply systems thinking and system dynamics tools and technologies to the field of software engineering, visit our website at www.stice.com. And for information about training courses and consulting on how to use systems thinking to improve your software business, or if you have any comments, questions, or requests about this video or other video series, please visit my company website, www.spdynamics.com, or contact me directly at my email address, jim.hart@stice.com. Thank you.